This is 6.6, lesson 1, and for this lesson we are going to multiply and divide monomials. So looking at this chart, we can see over here as our powers, and then these are going to be our actual written numbers. So we see over here 10 to the 0 power is actually 1, and we're going to talk in our next lesson about how to solve things to the 0 power and why they're 1. So for this lesson we just need to focus on the rest of them. 10 to the first power is just 10. 10 times 10 is 10 to the second power, which is 100. 10 to the second power times 10 to the first power is really 10 times 10 times 10, which is 10 to the third power, or 1,000. 10 to the third power is 3 tens, times another 10 is 4 tens, so that's 10 to the fourth power, or 10,000. 10 to the fourth power times 10 to the first power is going to be 10 to the fifth power, which is 100,000. And then 10 to the fifth power, so 5 tens, times another 10 is 6 tens, or 10 to the sixth power, which is 1,000,000. So I want you to notice a few things. First of all, our exponent over here matches our number of zeros behind the 1. And this only happens for tens. The other thing I want you to notice is when I'm multiplying, for example, 10 to the third power times 10 to the first power, I get 10 to the fourth. If you see, I have a 3 and a 1, and when you think, what can I do with those two to get to a 4, we add them. So if I see if that happens later on, 4 and 1 give me 5, 5 and 1 give me 6, this is going to be our first rule. So our first rule is product of powers. So to multiply powers with the same base, we add their exponents. Okay, up here, our base was always 10, but we will not always have the same base in a problem, and we'll see that here in a minute. But when we have the same base and we're multiplying them, we just add their exponents to simplify. So let's look at the expanded first. When I have 3 squared times 3 to the fourth, I have 2 3's for my first one. I have 4 3's for my second one, so I get 6 total 3's, or 3 to the sixth power. I could have just added my 2 exponents. So looking at our rule, if I have 2 to the 4 times 2 to the third, I can really just have 2 to the 4 plus 3, or just 2 to the 7th. Whenever we are doing these problems, I'm going to give you 2 methods. You can either use the expansion method or the rule. And I don't care which method you choose. I will show you both for every problem. So it's completely up to you which one you like better. So we have 5 squared times 5, and so when we expand that, that would be 5 times 5 for my 5 squared, times another 5. When I'm multiplying 3 5's together, I have 5 to the third power. So that's by doing it with expansion. I could do the rule, which is where I add my exponents. So I have 5 to the 2 plus, but my next number doesn't have an exponent. If it doesn't have an exponent, the exponent is 1. So I have 5 to the 2 plus 1, which is 5 to the third power. So again, I don't care which of these 2 methods you want to use. Our next one with expansion, we have 3 9's multiplied together, and then 2 9's multiplied together. So this is going to give me a 9 to the fifth power. Or, with my rule, I do 9 to the 3 plus 2, which is 9 to the fifth power. Letter C, when I expand, I have 2 2's, then I have 2 10's, and then I have 2 more 2's. Well, we can only combine things with same bases. So I have 4 2's multiplied together, so that's 2 to the fourth, times, I leave it as 10 squared. When I do my rule again, same bases can go together. So when my base of 2, I have exponents of 2 plus 2. And my 10 squared just stays 10 squared because I can't combine it with anything. So this gives me 2 to the fourth times 10 squared. So now we're going to take this rule and we're going to kind of further our understanding a little bit. So my next problem is 3 to the third power squared. So let's think for a second. When I have a number in parentheses, for example, the number 5, and I square it, this means I'm squaring whatever's inside my parentheses, or I'm doing 5 times 5. In this case, I'm squaring what's inside of my parentheses. So that means I am doing 3 to the third times 3 to the third. If I expanded that out, it would be, I have 3 3s from the first one, I have 3 3s from the second one, so that's going to give me 3 to the 6th power. Or, with my rule, I could think it as 3 to the 3 plus 3, or 3 to the 6. So be careful when I have these double exponents. It doesn't just mean I multiply by 2. It means whatever's inside the parentheses is multiplying it by itself that many times. So looking at our next one, I have 2 to the 4th power to the 4th power. So that means I multiply 2 to the 4th by itself 4 times. Then I still have another 2 squared. Now I'm not going to write out this many 2's, that's a whole lot. If you really wanted to, you can, but I'm just going to go ahead and use the rule. So my base is a 2 for all of these numbers, and I'm multiplying, which means I can add all of my exponents. So I have 4 plus 4 plus 4 plus 4 plus 2 gives me 2 to the 18th power. My last one here, I can leave my 5 to the 3rd, but I need to simplify this middle part. So I have 5 to the 5th squared. So that means I have 2 5 to the 5th powers. And then I still have to multiply by 6 to the 3rd power. Again, I'm not going to write out this many 5's. I'm just going to go to my rule. So my base is 5, and I add my exponents of 5 as a base. So 3 plus 5 plus 5. And then I still just multiply by 6 to the 3rd. I don't combine anything with it because there's no other bases of 6. So I get 5 to the 13th power times 6 to the 3rd power. Our next rule that we're going to look at is quotient of powers, or when we're dividing. So when we divide powers with the same base, we do the opposite as multiplying. We're going to subtract their exponents. So I want to start with the expansion again. If I have 5 to the 7th over 5 to the 4th, it means I have 7 5's on top multiplied together and 4 5's on the bottom multiplied together. Well, when I have the same number on top and bottom, we know that they can cancel. So I have 1, 2, 3, 4 5's that can cancel. So I'm left with 3. So that's going to be 5 to the 3rd. My rule, for example, up here, 3 to the 7th over 3 to the 3rd, I just subtract my 2 exponents, and that should say 3 to the 4th. So let's come down here for our examples. Our 4 to the 8th over 4 squared. So to expand it, I have 8 4's on top, divided by 2 4's multiplied together. Okay, so I can cancel out 2 of my 4's on top and bottom. So that's going to leave me 6 4's multiplied together, or 4 to the 6th. If I use my rule, I have 4 to the 8 minus 2, which is 4 to the 6th. For letter E, to expand, I have 5 negative 2's on top, and I have 2 negative 2's on the bottom. So 2 of these are going to cancel. I'm left with 3 negative 2's, or negative 2 to the 3rd power. For my rule, I would have negative 2 to the 5 minus 2, which is negative 2 to the 3rd power. Letter F, to expand, I have 5 2's, I have 5 3's, and I have 2 5's, over 2 2's, 4 3's, and 1 5. Same bases can cancel, so I can cancel 2 of my 2's, I can cancel 4 of my 3's, and I can cancel 1 of my 5's. So I am left with 3 2's. I have 1 3, so I'm just going to write that as 3. If you write it to the first power, that's also okay. And I have 1 5. Our rule, we would have 2 to the top minus bottom, so 5 minus 2, times 3 to the 5 minus 4, times 5 to the 2 minus, and remember if there's not an exponent, it's a 1. So simplified, that's going to give me 2 to the 3rd times 3 times 5.